Sometimes working with trigonometric integrals requires us to be a little bit creative with trigonometric identities. This is such a case. We have the integral from 0 to pi of the sine squared of t times the cosine to the fourth of t dt. What I'd like to do in this case is split up the cosine to the fourth of t, and I'll show you why in just a minute. I'm going to re-express this integral as the integral from 0 to pi of the sine squared of t times the cosine squared of t times the cosine squared of t dt. To help see why I did what I just did, let's recall that the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. Therefore, we can say that the sine of theta times the cosine of theta is equal to 1/2 of the sine of 2 theta, and therefore the sine squared of theta times the cosine squared of theta is equal to 1/4 times the sine squared of 2 theta. With that in mind, I'm going to replace the sine squared of t times the cosine squared of t. We'll have 1/4 times the integral of the sine squared of 2t times the cosine squared of t dt. This is, of course, still a definite integral from 0 to pi. Before we move on, I'd like to remind you of another trigonometric identity. The cosine of 2 theta can be expressed as 2 times the cosine squared of theta minus 1. By rearranging this equation, we can express the cosine squared of theta as 1/2 times the quantity of 1 plus the cosine of 2 theta. As an aside, the cosine of 2 theta can also be expressed as 1 minus 2 times the sine squared of theta, and rearranging this equation will give us that the sine squared of theta is equal to 1/2 times the quantity of 1 minus the cosine of 2 theta. You can verify the manipulation of the equation, but what I'd like to point out now here is that in our integral, we have a cosine squared of t. And by doing that, we can rewrite our integral. We have the integral 1/4 times the integral from 0 to pi of the sine squared of 2t, I'm not changing that at the moment, times 1/2 times the 1 plus the cosine of 2t dt. What we've just done is we've used, underline the wrong thing there. What we've just done is we've used a power reducing formula. It is so named because the power of the cosine of t has been dropped from cosine squared of t to cosine, the argument changed, of 2t, but the exponent is only 1. That is a big deal because we can integrate the cosine of 2t, for instance, where we can't directly integrate the cosine squared of t. At this point, what I'll do is I'll take the factor of 1/2 and combine it with the factor of 1/4 outside of the integral. We have 1/8 times the integral from 0 to pi, and then I'm going to distribute the sine squared of 2t into the parentheses that contain 1 plus the cosine of 2t. We get the sine squared of 2t plus the sine squared of 2t times the cosine of 2t dt. This may look like we've made matters worse. However, if we identify u as the sine of 2t, then du would be 2 times the cosine of 2t dt, and so we're just missing a factor of 2 with the cosine of 2t to have a du. So I'm going to make a little bit of room here and introduce a factor of 2 and then another factor of 1/2. What we've done is in that term that contains cosine of 2t, multiplied and divided by 2, so we have a du as we need. To keep things straight here, I'm now going to split this up into two integrals. We have 1/8 times the integral from 0 to pi of the sine squared of 2t plus 1/16 times the integral from 0 to pi of the sine squared of 2t times 2 times the cosine of 2t dt. The 1/16 coming from 1/2 times 1/8. For the integral on the right, we essentially have a u squared du, and we can integrate that using the power rule. For the integral on the left, we have sine squared of 2t. We have a power reducing formula for the sine function that we can use. Therefore, we can rewrite this as 1/8 times the integral from 0 to pi of 1/2 times 1 minus the cosine of 4t dt. Oh my gosh, I left out a dt here. When I wrote sine squared of 2t, I didn't write dt. Please don't tell your friends. Continuing on, plus 1/16 times the integral from 0 to pi of the sine squared of 2t times 2 times the cosine of 2t dt. This time for our application of the power reducing formula, our argument changed from 2t to 4t. That's because this came from a double angle formula from the cosine function, and anytime we apply a power reducing formula, we will double the argument. At this point, we're now ready to integrate. Because our first term has factors of 1/8 and 1/2, we know that that represents a 1/16. Our second integral also has a factor of 1/16 out front, so I'm going to factor the 1/16 out of the whole thing. The integral of 1 with respect to t is t, and the integral of negative cosine of 4t with respect to t is minus 1/4 times the sine of 4t. Continuing on, we effectively had a u squared du, and so when we integrate the sine squared of 2t with respect to t, we're going to use the power rule. We get plus 1/3 sine cubed of 2t, all of which is evaluated from 0 to pi. When we put either 0 or pi into sine of 4t or sine of 2t, we get zeros for both of those terms. Our answer then becomes 1/16 times pi minus 0, or simply pi over 16.